Is a slotted ALOHA efficient in sharing the link to service users? Let's find out. Suppose we have n nodes, and in our setting, all nodes always have fresh frames to send. Each node transmits in a slot with probability p. We try to find out the maximum efficiency of a slotted ALOHA. Each time slot, similar to our example, could be an empty time slot, a time slot with a collision, or a time slot where there is a successful transmit. The probability that a time slot is successful is the probability that one of the nodes transmits and n-1 of them do not transmit. The probability that a given node transmits is p. Therefore, the probability that a given node has success in a time slot is p times 1 minus p to the power of n-1. P for the transmitting node and 1 minus p to the power of n-1 for nodes not transmitting. The probability that any one of n nodes has a success is np times 1 minus p to the power of n-1. Therefore, when there are n nodes that are active and have frames to send, the efficiency of a slotted ALOHA is np times 1 minus p to the power of n-1. To find maximum efficiency, we need to find the value of p that maximizes the probability that any one of n nodes has a success. This optimum value is 1 over n. Using this value of p when there are many nodes in the system, meaning when n is approaching infinity, the efficiency of a slotted ALOHA approaches 1 over e, which is 0.37. Therefore, at best, slotted ALOHA uses the channel for successful transmissions only 37% of the time. Another version of ALOHA, proposed and used even earlier than a slotted ALOHA, is pure ALOHA. Pure ALOHA is simpler. It does not use synchronization among the nodes for marking the beginning of the time slot. Therefore, the frame send time might be different among different nodes. In pure ALOHA, when frame first arrives, the node transmits it immediately, without waiting for a specific time slot start time. If collision happens, the node waits for a frame time, then reattempts transmission with probability p. This model increases the possibility of a collision, because a frame sent at time t0 might collide with frames starting the same time, as well as frames whose transmission has started before and not finished yet, and frames whose transmission might start during the time needed for the transmission of the current frame, which is from t0 minus 1 to t0 plus 1 frame time if the current send time is t0. Therefore, the probability of success for a given node will be probability that it transmits at time t0 and no other node transmits at the time range t0 minus 1 to t0 plus 1, which is a time length of 2 frames. This will result in probability p times 1 minus p to the power of 2 times n minus 1. Similar steps of finding the optimum p and finding the efficiency when n approaches infinity will yield the value of 0.18 for pure ALOHA, which is even worse than slotted ALOHA.